stuff. So we were going over relativistic addition of velocities. SLs, this is not for you. You don't have to know this for the exam. But just for fun, you can listen in a little bit. If you have something else to do, you can not pay attention if that's what you want to do. We had Arsha riding a bicycle. Okay? Arsha is in a reference frame. We're going to call that reference frame S prime. You have to think, in order to understand special relativity, you have to think in terms of reference frames. So he's in S prime reference frame. It's moving because he's riding his bike. And that reference frame is going to move a certain distance. We call that X prime. So it's going to be here. And he's going to be here. And he's going to have thrown a penguin while he's riding his bike. So the penguin's going to be up here, moving, and it's going to be moving at a velocity v. So we say that the distance the penguin moves from Arsha's point of view is vt. Okay. We're looking at it in reference frame S, so we're in a different reference frame. Not S prime like Arsha's in, we're just in S reference frame, and from our point of view, we're sitting still. It's important to note that from Arsha's point of view, he's sitting still too. We're moving backwards, right? But we're not going to confuse ourselves with that. We're just going to say, no, this is the proper thing. We're looking from here. Arsha's moving because he's riding his bike, and the penguin's being thrown. For us, we see a distance that the penguin moves x. That's the distance the penguin moves in our reference frame. Now, Galileo came up with the idea for reference frames, and he said this is very it's kind of handy because we can add together, bless you, these two distances, and we can just say the distance we see the penguin move is the distance that Arsha moves on his bike plus the distance that the penguin moves, which is vt. So this is kind of drawn with these S frame and S prime. We say S prime moves, so the bike moves, and the penguin moves, and we add those together to get the distance that the penguin moves that we see. This is x. So it's how far Arsha moved on his bike plus the penguin's distance in his reference frame. Okay. This is what Galileo says. And it's important to understand that from Galileo's perspective in the 1600s, our time and Arsha's time are the same. It's all the same time. Okay. And these things are true. So if you just subtract vt, you get this one. This is the speed of the penguin that we see. And we say, just take the speed of the bike, which is the speed that Arsha's reference frame is moving, plus v, the speed that he throws the penguin at. If you add those two together, that's the speed the penguin moves for us. It's all easy, easy peasy. Until Einstein comes along, he says, no, that's not right. He says we have this thing called gamma, and he says our time is different, Arsha's time is different from our time. We say we got to gammify these equations. And when we do that, we plug in, we say x prime is actually, it's gamma times x minus vt, and x is this, so we put that in. And we differentiate between Arsha's time and our time, because we know that if we get moving fast, they're going to be significantly different. I took this gamma and I put it under here, and it kind of disappears from the rest of it. And then we're going to just add this VT over and subtract the x prime over gamma to the other side. And I'm just gonna try to quickly finish this so you guys can see this, because some of you guys are writing a math contest, which is cool. So we get, on this side, we have VT equals gamma times x prime plus VT prime minus x prime over gamma. So we have that. I'm going to just do this. I'm going to multiply this last term by 1. I'm going to multiply it by gamma over gamma, because we can do that. Go back up here. And then if we continue that on, we're going to have still VT on the left. And we're going to have gamma times x prime plus VT prime. And because this is gamma over, because this is x prime gamma over gamma squared, we can put that term inside the brackets now. And we can say this is x prime over gamma squared. Does that make sense?
Yeah.
Did I do that right?
Yeah.
Okay, good.
This needs to be minus. This is negative x prime.
Yeah, you're right. See, that's why I asked. Yeah, that's a minus. Thank you, Russia. And then we have to do a little aside here with this term. Because now we have negative x prime over gamma squared. We're gonna do a little side trick with this term. We're gonna say, we're gonna expand this gamma. We're gonna say that's 1 over square root of 1 minus v squared over c squared, all squared. That equals negative x prime times 1 minus v squared over c squared. Does that make sense?
Yes.
Okay. Because the square takes away the square root, and then we flip it over and it ends up on top. And so that's going to equal negative x prime, if we distribute, plus x prime v squared over c squared. Is that legit? Did I do that right?
Yeah.
Yeah.
Think it's okay? And so now we take that and we put it back in to the original function, and we're going to have VT equals gamma times x prime plus VT prime minus x prime plus x prime v squared over c squared. Why did I do all that?
Cancel out x prime.
Great. So these are going to be gonzo, which is kind of nice. So we're left with VT equals gamma VT prime plus x prime v squared over c squared. What are you seeing I can do here now?
Factorial.
Good.
Yeah.
That's excellent. So we can get rid of a v out of both of these, right? We don't worry about the gamma, it's being multiplied, so I can just take it out of here and here. And so this is kind of nice because we end up with the formula for t. So t equals gamma t prime plus x prime v over c squared.
It's
Also-
x prime. Bro, x
Isn't it
prime.
X? Yeah. So it's actually X prime.
Oh, yeah.
It's X prime.
Sorry, that's a prime. You're right, you're right. It's good that I have you guys watching me. And that's 1/2 of the equation. And you can also say, if you move this around, you can say that x equals gamma x prime plus vt prime. With me? Kinda, sorta?
Yeah.
It's a lot. It'll be on video, so we can look at it later. I'll laugh at all my mistakes. Einstein is going to continue here. And he's going to say, okay, if we want to find the velocity of the penguin from our point of view, that's going to equal delta x over delta t, right? So delta x is gamma delta x prime plus v delta t prime. And delta t, as we see here, is going to be gamma delta t prime plus v delta x prime. So I just took this one and kind of flipped it around to the other side. Over c squared. That has to be over c squared. And then if we kind of, well, you tell me, what can we do with that right away?
Cancel
We can get rid of our gammas, which is quite nice. And then we can, if we multiply each of these by 1 over delta t prime, which is, we can do, that's chill because it's just multiplying by 1. And what we end up with is delta x prime over delta t prime plus b all over 1 plus v over c squared times delta x prime over delta t prime.
Isn't that just v?
Well, that's v, that's actually u prime.
U prime, yeah.
Yeah. So there's kind of like a thing you have to see. Alright, I saw it right away.
Wait, but u prime you said is the bug's velocity for us.
U prime is,
I think we just kind of messed up with the name. Then penguin velocity for bike, which is I think what you're referring to as v. Says v.
say it again.
We said that penguin velocity for bike is v.
Yes.
So that's the bike velocity for us, u prime. Is that right?
Yes, that's right. This is the velocity of S prime reference frame,
So the bay.
which for us is the bike.
Yeah.
This is the bike's velocity.
Oh, I see. Okay.
And that's delta x prime, like the distance that that reference frame travels over the time in his time. Yeah. And so if we look at this, and we have this here and here, then we can say that's u prime, right? So, after all that, we get to our equation for u. We're still, this is all equal to u, which is the velocity of the penguin for us. This is what we're trying to find. And so this is u prime, which is the speed of the other reference frame, so the bike's speed, plus v, the speed he throws the penguin at, for him, over 1 plus u prime, and I put the u prime in front, times v over c squared. So this is Einstein's formula for relativistic addition of velocities.
So
It's nice to know where it came from. And So just say that you threw something, let's say you're riding on a rocket ship that's going 0.6 C and you shoot a missile from the top at 0.8 C. If you just add them together, what do you get?
1.4.
You got 1.4, right? So if you're on a rocket, Annie's riding a rocket. Anna is riding a rocket. And she gets her missile launcher up here. And she fires a missile out of it. And it's going 0.8 relative to her, and the rocket's going 0.6. If you just add them together, you get 1.4, right? Is that allowed?
No.
No, not allowed. This gives us the proper way to do that. So let's plug it in and see if we can get it. So we're looking for u. U prime is the velocity of the reference frame. So in this case, that's the rocket. So if we're down here, we're all watching from S reference frame. She's on the rocket, which is S prime, right? It's moving at a speed of u prime. So plug in the u prime and plug in the v and see what you get for the velocity that we would see. Try to do that. You'll notice you don't have to worry about the c squared. You don't have to put in the 3 times 10 to the 8 or anything, because these velocities are in terms of c, so the c's just cancel it. Let's just do that quickly. Over 2.4, what is it?
0.946.
0.946? Will this number ever be more than 1?
No.
No. So you can do 0.99 and 0.99, but it will never get over 1. Okay, so that's how you do this problem. Almost for sure IB will put a problem like this on the exam, but you just use the formula and you plug it in. You just have to know what's what. Okay, that's all for the video. Are there any questions? Does that kind of make sense? I know it's complicated, but